Hey, so in this video, I would like to show you how to solve all problems in the practice exam. And at the same time, I would like to do some short review for you. All right? So basically, let's remind you about two main problems in this course. So in this course, we consider two problems. The first problem is tangent line problems, and the second problem is area problem. Right? In the last chapter, we did area problems. So we use definite integrals to find areas. And in the previous chapters, we study limits, we study continuity, we study derivatives and how to use derivatives to analyze a function. We use the first derivative to find tangent line, to find the slope. Derivative is the slope, don't forget about that. We use the first derivative to find intervals where the function is increasing, decreasing. The function is increasing if the first derivative is positive. The function is decreasing if the first derivative is negative. And if the first derivative is zero, that is critical point. Okay? And we use the first derivative to classify local maximum or local minimum or some local maximum looks like this, right? Looks like this. And the first derivative is equal to 0. And from here, the derivative is decreasing and then increasing. Means when x passes through this point, the first derivative changes the sign. That is the most important. Okay? And we also use the second derivative to find intervals where the function is convex or concave. So convex looks like this. Concave look like this. And based on the behavior of convexity and concavity, we will say we would use a second derivative to classify extrema. If the function attains extrema at some point and the second derivative at there is negative, so that point should be maximum because the second derivative is negative, meaning the function is concave. Concave should look like this, and that point should be maximum. If the second derivative is negative, is positive, that is convex, so that point is medium. All right, that's a very brief about the first derivative and the second derivative. And we have different rules to find derivative. So please make sure you have formula sheet during review. So please have that with you. Do homework, solve all problems in here, and then try to memorize some basic formulas. And after that, we solve some applied problems, some optimization problems. Basically, we have some real-world problems. In this practice exam, we have problem how to minimize or maximize distance from one point to a curve. That is problem 9. And then we use differential to approximate the value of the expression. In this case, I will show you in detail about that. And then we use we have some problems on integration. Again, right? I did not grade the test today, but I hope that the average would be 80. Some students did really well. Of course, we still have some not really well, but that's fine. We still have a room to improve. And we need to memorize some basic formulas for sine, for power function, for 1 over x, and then by substitution we need to know how to recognize what kind of substitution is good and what kind not good, and we know how to use definite integrals to find area. So in the practice test, I will not give you Riemann sums, so I hope you will happy with that. Okay, now since we still have an additional test, So I will tell you about additional test. The additional test will cover the last 10 questions. Let's say that the last 10 questions. So that means from question 6 to 60, because that is some kind of review, right? You do review and you do additional test for your credit. Okay. All right. The first problem. So because when I create this practice exam, I go from integration. I go from the last to the beginning. So I will show solution from integration and then go back. Or maybe we can go. Let's say we go from the last. Okay. So the first topic in this course is the limit. Let's find the limit of 2x squared plus 14x plus 12 over x plus 6 when x goes to -6. Of course, that is very old topic, find limit. And we have many techniques to solve limits. Factorization, we have rational function. If you plug this number into the function and you get a finite number right away, you are good. That is your answer. Okay? In this case, you have fractional function. You have fractional function, you plug -6 into this function, you get what? In here, you get 0. So you have 6 minus 6, which is 0. And what is on the top? On the top, you have, I would say, 2 and then -6 squared plus 14 times -6 plus 12. Probably, you also get 0. So that means our limit has the form 0 over 0. But that's not that bad, That means x equal to -6 is the common 0 of the top and the bottom. That means we can factorize the top by x minus 6, x plus 6, and then we cancel that out. We get a very good function. Make sense? Okay, let's do that. So again, in this problem, we need to know how to factorize a polynomial. In this case, just quadratic polynomial. So I write the limit of, since 2 is common, right? 2x, 14 and 12, I would write 2 in here, I have x squared plus 7x plus 6 over x plus 6, x goes to -6. And let's factor this by 6, x plus 6. So I get a limit. I can bring 2 out of the limit because that is just coefficient. So if I write x plus 6 in here, so what do I have in this part? Here we have x, here we have x squared. So that means here we need x, right? And then now we move to the free coefficient. Here I have 6, here I have 6. That means here I should have plus 1. So I have x plus 1 over here, I have x plus 6 in here, x goes to -6. And then in this step, we can cancel x plus 6, x plus 6. I have 2 times limit of x plus 1 and x goes to -6. And now we just plug -6 into this function to get the final answer. That is 2, -6 plus 1, which is, here is -5, and I have -10. That is the final answer. Okay? Next question. Find the second derivative of the function. What is the second derivative? The second derivative is the derivative of the first derivative. So basically, in order to find the second derivative, we need to find the first and take the derivative one more time. Okay, let's do that. Let's find the first derivative. We have different rules, right? Product rule, quotient rule, sum rule, different rule, the chain rule, don't forget. So in this case, you see, we have 8x psi squared. But a is just a number, coefficient, so we don't have to take the derivative of 8. I mean, we can bring 8 out of the derivative. So we always can write 8 in here. Make sense? And then what is inside? We have x and psi squared. X times psi squared means the product of x and psi squared. So first we need to use the product rule. Let's do that. I have x derivative psi squared of x plus x psi squared of x derivative. So that is the product rule. Derivative of the first times the second plus the first function times the derivative of the second. Derivative of x is just 1. I have 8 psi squared of x plus x. But derivative of psi squared of x, what's that? In this case, we need to use the chain rule because we have two functions in here, square and psi, right? And the psi function is inside the square. So when we apply the chain rule, let me remind you about that. F of g derivative is derivative of the outside function, evaluated at the inside, and then times derivative of the inside. Okay, so derivative of the outside is derivative of square. That is 2, right? The power, but 2 reduced by 1, so you have 2 in here. But evaluated at the inside, that means 2 sine x, right? And then multiplied by the derivative of the inside means derivative of sine, which is cosine. So that is the first derivative. Okay? And now you can take the second derivative. Almost the same. You have a in here. In fact, derivative of sine squared. We just took derivative of sine squared in here, right? Which is 2 sine cosine. So I just repeat that. I have 2 sine of x cosine of x. Right? And then we take the derivative of this part, the whole things. You see, here we have product of 3 functions, but that's okay. Product of 3 functions, we use the product rule. I write 2 in here. Derivative of x is 1. So 2 sine of x cosine of x plus 2 x. So see, don't when we take product rule, you see, we just move the derivative along terms in that product. So first you have derivative of x, and then you have derivative of sine, then you have derivative of cosine. So in this case, I have 2x, derivative of sine is cosine, you have cosine, and then derivative of cosine is 2x sine x, and then negative sine x. Done. On the final exam, you should not simplify your answer. Make sense? If I just ask you to find the first and the second derivative, just leave in this form or in this form. Do not need to simplify. So please repeat the product rule, the chain rule. Next, find an equation of the tangent line to the graph of a function at the given point. That is problem 14, right? I just go in the odd order. The function is y equal to x plus 1 over x minus 1. And the point is 1 over 2, make it 3. So we need to find a tangent line at a given point. In order to find a tangent line, the first step we need to do is to find derivative, because derivative is the slope of the tangent line. So first I have to find derivative. Derivative of this, since we have quotient, right? We apply the quotient rule. What is the quotient rule? F over g derivative, f derivative of g minus fg derivative over g squared. That is the quotient rule. F derivative is just 1, so I have 1 times x minus 1. G derivative is 1 minus 1 times x plus 1 over x minus 1 squared. Let's simplify that. So here is just 1. With just 1, I can erase this. I have x minus 1 minus x minus 1. Don't forget. here we have to open parentheses, and each time when we open that and we have negative in the front of the parentheses, we need to change the sign, right, of all terms inside. So I have negative x and minus 1. X minus 1 squared. X will be cancelled out. Negative 1 with negative 1 is negative 2, or x minus 1 squared. All right. And here we already have derivative, but we need to find the tangent line. From here, I can find the slope. The slope is equal to the derivative at x equal to 1 over 2, because we need to find the tangent line at this point, right? So I just plug 1 over 2 into this derivative. I get negative 2 over 1 over 2 minus 1 square, which is negative 2. 1 over 2 square. 1 over 2 square is 1/4, and I flip that, I get negative 8. The slope is negative 8. So now we have the slope. We have given point coordinates in here. We just write the equation. That is y minus y0 equal to negative 8. The slope, right? X minus 1 over 2. X minus 1 over 2 is x minus x0. So that is y minus negative 3 equal to negative ax plus 4. You can simplify that, you can make a very good equation that looks like y equal to negative ax, and here plus 3 plus 4, I bring 3 into that side, I get plus 1. And that is the final answer for that question. Next, question 13. Use the product rule or the quotient rule to find the derivative of the function. Product rule or quotient rule, right? So we just solve problem like that. That is problem 15 for the second derivative. So basically, I just repeat what I have done over there. So I hope that you can do yourself. Okay, and you check your solution on website. In this case, we use the product rule, right? We have product of two functions. Use the product rule. But anyway, let me show that for you. Y prime. 7 is constant. We always can bring 7 out. Here product. So I take product of t4 derivative times cosine of t plus t to 4 times cosine of t derivative. That is the product rule. Derivative of the first times the second plus the first time derivative of the second. That is 7. Here we use power rule. T to 4 derivative, bring the power down, reduce the power by 1. The power rule. Times cosine of t plus t to 4 derivative of cosine is negative sign. Done. And question 12. Use the rules of differentiation to find the derivative of the function. Find the derivative of the following function: 6 square root of x plus 9 of x, 9 root of x. But we have radical functions in here. But radical functions can be converted into power functions. And then let's convert them into power form and take derivative by using the power rule. So I have 6 x square root means x to 1 over 2 plus 9. X to this means x to 1 9, right? 1 9. And then I take the derivative of this function. 6. Power rule says when you take the derivative of power function, you bring power down and you reduce power by 1. Plus 9, bring the power down and reduce the power by 1. Done. You can live like that if I ask you to find the derivative. Don't need to simplify. But in case when you need to find tangent line something, you have to simplify that. Oh, so it's good. Okay, I see that I don't have problems to find or x squared tangential horizontal, but that's good. Horizontal means derivative is equal to 0. Now let's move to the sixth problem. Application of the first and the second derivative. Problem 6. We have some function f of x equal to x cubed minus 3 over 2 x squared, and on interval -3 to 2. Find the absolute extrema of the function on the closed interval. Extrema on that interval. So let me repeat the instruction how to find absolute extrema. And I hope you still remember that finding absolute extrema is easier than finding relative extrema, because for relative extrema we need to find to classify which is maximum, which is minimum. But for absolute extrema we don't have to do that. We only need to work with numbers. The first step, we need to find derivative and set it equal to 0, or find where the first derivative does not exist. Means we have to find all critical points in the given interval, right? In the given interval. So let's take derivative of this function. That is 3x squared minus 3x squared over 2 times 2, right? 2 times, just 2 times. And then we have 3x squared minus 3x. So you set it equal to 0, you get 3x, x minus 1 equal to 0. From here you get x equal to 0 or x equal to 1. And then we say 1 and 0 are in this interval, right? So that means all critical points are in the given interval. The next step we need to do is find function values. At 0, at 1, at -3, and at 2. That means we have to find function values at all critical points in this interval and at 2 endpoints. So at 0, we plug 0 into the function. F of 0 is 0 cubed minus 3 over 2, 0 squared, which is 0. Right? Don't forget, don't be confused, because we are working with function values, not with the derivative. So in this case, you have to plug all these numbers into the original function. Similarly, you can find 1. I can find 1. I plug 1 into this. I get 1 minus 3 over 2, which is -1 over 2. I circle 0, -1 over 2. And then I plug -3 into that. I get -27 minus 1 over 2. And here 27, right? That means 3 over 2, 27, -3 over 2, 27, that is -81 over 2. And at 2, you can find at 2, I plug 2 into that, I get 8 minus 3 over 2 times 4, which is 2, 6, which is 2. So we have 4 values, 0, -1/2, 2, and -81 over 2. From here, we can pick the smallest and pick the biggest, and we do conclusion. The absolute minimum is -81 over 2. It's negative. I hope that my computation is correct. Yes, -81 over 2. And the function attains absolute minimum at -3. And absolute maximum is equal to 2 at x equal to 2. That's it. Alright, that is question 6. Let's move to Question 7. The function is f equal to negative 5x cubed plus 15x plus 6. Find the critical numbers for f. So let's recall what critical points are, right? We have two cases. We take the derivative, the first derivative. If the first derivative is equal to 0, those points are called critical points. But if the first derivative does not exist at some point, those points are also called critical numbers or critical points. So I would say, okay, I write here maybe f derivative equal to 0 or f derivative does not exist. Does not exist. But our function is polynomial. We don't have the second case, right? Because polynomial exists everywhere, and derivative of polynomials also exists everywhere. So we concentrate on the first case when derivative is 0. Derivative 15 negative 15x squared plus 15 you set equal to 0. 15, so from here I just simplify 15, I get minus x squared plus 1 equal to 0, or x squared equal to 1. From here I get x equal to plus minus 1. So it means the function has two critical numbers, plus and minus 1. The second question, they ask us to find all open intervals on which the function is increasing or decreasing. So that means we have to do our favorite chart, right? Our favorite chart. The chart has 3 rows. In the first row, we have domain. It's about x. The second row is about derivative, and the last row is about y, right? So the function has domain from negative infinity to positive infinity because that is polynomial. I write here negative infinity, positive infinity. And in the first row, I have to express all special numbers. In this case, we have critical numbers. That is plus and minus 1. So I write here negative 1 and 1. We finish with the first row. Let's go with the second row. The second row have derivative. Derivative at 1 and negative 1 is 0, right? So 0 in here, 0 in here. We need to figure out what side of the first derivative in this interval, and in this interval. We need to do that because if the derivative is less than 0, means the function is decreasing. If the derivative is bigger than 0, the function is increasing. So let's do that. I will pick one part from here, one part from here, one part from here, just to test, right, the sign of the first derivative. Between negative 1 and 1, I can pick 0. And I plug 0 into the derivative because we are working with the derivative. I plug 0 into this, I get what? 0 plus 1, which is 1, positive. And then I pick 2. I plug 2 into this or into this. I say negative 4 plus 1, negative. Similarly, I can pick negative 2. I plug negative 2 into this, I get negative. Right? I get negative because negative 4, negative 3. So what does it mean? That means in this interval, the function is decreasing because that is negative. Decreasing from this to this point, right? And here, from here, the derivative is 0. Change the sign, go up, right? And then go down. And you can, based on this, you can do conclusion. In this interval, and in this interval, the function is decreasing. And in this interval, the function is increasing. Decrease, increase, decrease. If you want, you can write decrease where? Negative infinity to negative 1 union with 1 infinity. Increase on negative 1 and 1. And they ask apply the first derivative test to identify the relative extremum. So actually, that's what we did. I hope you still remember that problem on the test. On the test, some of you just wrote this chart, and you didn't mention, based on this thing, the function is decreasing and increasing. This point should be minimum, right? And this point should be maximum. If you did not point out this, you lost some points, at least 2 points, you know. So you have to write here minimum, here maximum, because they ask you to identify the relative extremum. So that is local minimum and this is local maximum. Yeah, we finished this problem. All right. Let's move to the next problem, problem 8. Here we need to use the second derivative to find all intervals where the function is concave or convex. Problem 8. We have function y equal to x4 minus 9x cubed. Find intervals where y is convex or concave. Okay, let's remind you, right? If the second derivative greater than 0, that is convex. If the second derivative less than 0, that is concave. Okay, so we need to find the second derivative and set it equal to 0 in order to find all inflection points. Maybe that is inflection point. So let's find the second derivative. What from equal to 4x cubed minus 27x squared, and then second derivative is 12x squared minus 54x. Let's set it equal to 0. From here, I have x or 12x minus 54 equal to 0. So x is 0 or 12x minus 54 equal to 0 or x equal to 54 over 12. So the function has 2 inflection points. Okay, now let's make a chart for the second derivative. And based on the chart, we will do conclusion. I erase this, I make a chart in here. The first row is for x, the second row is for the second derivative, and the last row is for the function. So x is from negative infinity to positive infinity. 2 inflection points. I write 0 in here and then 54 over 12. Right? At 0 and 54 over 12, the second derivative is 0. So I have 0, 0 in here. Similarly to the previous example, I need to pick one part from here, one part from here, one part from here, and plug them into the second derivative to find the side of the second derivative. So from here, I can pick 1 because 1 is between 0 and this number. I plug 1 into this. I get 1 is positive, here is negative, so here is negative. I plug negative 1. I get negative in here, but this negative, that means this is negative. The whole this negative times negative would be positive. Positive in here. So probably you can pick for example 100, let's say that. 100 is bigger than this, I don't want to guess. Right? Just pick 100. You plug 100 into this, you get positive, positive, which is positive. Perfect. So that means in this the function is convex. In this the function is concave. And in this the function is convex. What does mean convex? Convex means looks like this. Concave looks like this. And convex looks like this. In case if they ask you to use the second derivative test to classify relative extremum. So first you need to find all relative extremum all critical points in the first derivative. And then you plug all those in the second derivative. Okay, let's do that. I will keep the second derivative in here. For the first derivative, I set it equal to 0. So from here I have x squared 4x minus 27 equal to 0, right? And then I have x equal to 0 or x equal to 27 over 4. That is from here. So I have only two critical points, right? I plug 0 into the second derivative. I see the second derivative at 0 is 0. That is the inflection point. No extra mile over there. And then I plug 27 over 4 into the second derivative. That means I have 12, 27 over 4 square minus 24 times 27 over 4, right? Basically, you don't have to do that because we only need to find the sign. So I would say that is 27 over 4. I just print it out because x is common. And then 12 times 27 over 4 minus 54. And this obvious that this number is bigger than 0. Because this is bigger than 0. Here we have 3 times 27 minus 54, which is positive. So this is positive. You see, the second derivative at this point is positive. That means this point should be minimum, local minimum. That's how we can use the second derivative test to classify extra time. Okay, so finish with this problem. All right, so let's move to the next problem, problem 9. You have some circle, and this circle looks like this. It's just a half of the circle. The radius is equal to 5, and the center of this circle is at the original. What length and width should the rectangle have so that its area is maximum? So we consider all rectangle in here, right? So for example, this is x, this is negative x. So when you move x, you have different rectangles, and they ask us to find x and y is y. So that the area of rectangle is maximum. That means we have to maximize area of rectangle. Okay. First, we need to do is to find the area of the rectangle because we don't have the area. If we don't have the area, how can we maximize that, right? So find the area of the rectangle. Find the area. The area of this rectangle is equal to x times y. Again, you know, in such problem, we always have function of two variables, x and y. But this is the relationship we have. X times square root of 25 minus x squared. That is y. So basically, I can replace y by this function, right? That is x. 25 minus x squared. So now we have a function of one variable. And the only thing we need to do is to maximize or to find maximum of this function when x goes from -5 to 5. Makes sense? So that means we have to find derivative of this function, find all critical points, right? And then see where the function is maximum. So let's say, f of x equal to x. 25 minus x squared. Let's find the derivative of this function. f derivative of x is equal to product rule, right? X derivative is just 1. I have 25 minus x squared plus x times the derivative of this guy. But the derivative of this guy can be found by using the chain rule. But you have two functions in here. The outside function is square root, the inside is 25 minus x squared. So by using the chain rule, I have to take the derivative of the outside first. That means 1 over 2 times 25 minus x squared. And then multiply by the derivative of the inside, which is negative 2x. And then I simplify 2. You see, 2 with 2 here will be simplified. I have the following one. I have 25 minus x squared. Here x with x and negative, I would have minus x over square root of 25 minus x squared. That is our derivative. Okay? So, in order to find maximum of this function, first we need to find the derivative, and then we set it equal to 0, right, to find all critical points. Let's set it equal to 0. Let me erase the problem here, so we have more space. When we set it equal to 0, I mean, here we need to use the trick, right? We don't have to use multiply. We don't have to use cross multiplication. I just bring this into another side. So I get 25 minus x squared equal to x over 25 minus x squared. And only from this step I will use cross multiplication. From here I multiply this guy with this guy and set equal to x. So I have 25 minus x squared equal to, here should be x squared, sorry. It should be x squared equal to x squared. And then you have 2x squared equal to 25, or x equal to plus minus square root of 25 over 2. You see? And you would guess that when x equal to plus or minus of this, you make the chart. Let me erase this. I keep the first one. I make a chart of x negative 5, negative 25 over 2, 25 over 2, and 5. And here, derivative, current function, this equal to 0, And between this, I can pick 0. I plug 0 in the derivative. This part is 0, this part is positive. So I have positive in here. Right? This is very interesting. 5. 2 times. No, mention that this is our function. Actually, in this case, we have to find global maximum, global minimum. We have to find global maximum because we need to maximize the area. So we don't need to do the chart. Yeah, sorry for that. We don't need to do a chart for global maximum. Once we already get all these values, right, critical points, we plug all critical points into the function and compare with 2 endpoints. So we are done with that. So when I plug that plus minus to that, we have the following thing. We have the following. That would be, but x is positive, you know, so I have square root of 25 over 2x times 25 minus 25 over 2, right? Square root square. Just take that. And then here you get 25 over 2. This equal to 25 over 2. Because this is square root of 25 over 2. And then inside you still have 25 over 2. So you multiply, you get 25 over 2. That is 2 endpoints. At negative 25 over 2, you get 25 minus square. Again, you get 25 over 2, right? And you get negative 25 over 2. Negative 25 over 2. I will show you the picture again, you see. And when x at two endpoints, the area is just 0, so there's nothing to do with that. So actually, that is our solution. The maximum area is equal to 25/2 when x is equal to square root 25/2. Why do we have negative in here? Because this is the circle, right? If we have negative square root 25/2 in here, we will have negative square root 25/2 in here, which is symmetric, So that is not something surprising. So that is about question 9. I think we still have other questions, but I would stop my first video at this problem. I will make another video for you on integration. So you have that soon, okay?